Good students. From our previous lesson, we discussed sorts. We looked at the rules for manipulating sorts and we saw so many problems concerning sorts. Today, we are going to concentrate on simplifying sorts that involve brackets. Now, just as in algebra, sorts containing brackets may be expanded and multiplied out in the same manner as in algebra. Check it out here. I have n times a plus b in a bracket. In algebra, the term outside the bracket, which is n, multiply everything inside the bracket. And that is why we now say m times a, we have am, and then m times b, we have bm. Check this one too. m plus n in the bracket times a plus b in another bracket. How do we carry out this expansion? If you can remember, this n will multiply this and we will also multiply this b. And that gives us an plus bn. In the same way, the n here will multiply this a and will also multiply this b to give us an plus bn. So see, that is what we have been doing all this while when we are dealing with algebra. And in doing so, take note of sign rules. What are the sign rules? If you can remember, we said plus times plus gives you plus, minus times minus gives you minus, plus times minus gives you minus, and then minus times plus gives you minus. So those are the sign rules I'm trying to say. We should always take note of them when we are expanding any brackets given to us. So all these concepts, as you already know them, can also be applied in simplifying sorts. Take for examples, we have the following to look at. Simplify the following. The first question here is 2 root 3 bracket open 3 root 5 plus root 3 plus bracket. Now, we will pick and follow these examples one after the other. The second one is open bracket 2 root 12 minus 3 plus your bracket. Open another bracket 2 root 3 plus 1 plus your bracket. And then the third question here is open bracket 3 plus root 2 plus bracket all squared. And the fourth question here we have 50 minus 3 root 2 open bracket 2 root 2 minus 5 plus your bracket minus 5 root 32. And then the last one here we have open bracket 1 minus 2 root 2 all divided by 1 plus 2 root 2 plus your bracket all squared. So I want us to pay attention and see how we can arrive at the solutions to each of these questions. 2 root 3 open bracket 3 root 5 plus root 3. So as I have explained earlier, the term outside the bracket here is 2 root 3. That means this 2 root 3 will have to multiply 3 root 5 and also root 3. That is, the whole of this will multiply this and will also multiply this. Are we following? So 2 root 3 times 3 root 5. The 2 here will multiply this 3 to give us 6. And then the root 3 will multiply root 5 to give us root 15. Then we now have plus 2 root 3 times root 3. You see there is no number before this square root and it's the same thing as 1. So 2 times 1 will have 2. And then root 3 times root 3. If you can remember, it's root 9, isn't it? And root of 9 is what? 3. So you have times 3. And therefore, you have 6 root 15 plus 2 times 3 is what? 6. And here you have your final answer. Because we cannot simplify this one further. The 15 here does not have any number as a perfect square that can go into it. So we leave it like that. Are we following? I think that is okay. Right, let's take the second question. We have open bracket 2 root 12 minus 3 open bracket 2 root 3 plus 1. Now, before we proceed, I want you to observe the first bracket here. We have square root of 12, isn't it? And square root of 12 is not in its basic form, so we have to change it to its basic form by checking out the factors of 12 such that one of them is a what? Perfect square. And if you can remember very well, 4 times 3 will give us 12. And therefore, root 12 is the same thing as root 4 times 3. And the root of 4 is 2, so we are going to have 2 root 3. So that instead of root 12, it becomes 2 root 3. Right, now we are going to have this one to be 2 times 2 root 3 minus 3. Now you see this 2 was already in our question, isn't it? And this 2 is from the simplification of root 12. And then we now have 2 root 3 plus 1. Now this 2 definitely will have to multiply this one to give us 4 root 3, then minus 3. Then we have this bracket 2 root 3 plus 1. And here we go. Just as I explained earlier, this 4 root 3 will multiply everything inside this bracket, and this minus 3 will also multiply everything inside this bracket. Therefore, we are going to have 4 root 3 times 2 root 3. That will give us what now? 8 root 9. And what is root 9? 3, isn't it? So we don't need to waste our time putting root 9, we will just put 8 times what now? 3. 8 times 3. So you now have 4 root 3 times the same 4 root 3 now multiply this 1. And that will give us plus 4 root 3. Then we have minus 3 times 2 root 3. Minus 3 times 2 root 3. I know that this 2 root 3 is positive, so minus times plus is minus. That's our sign rule, and that will give us minus 6 root 3. That's 3 times 2, 6, isn't it? Then we now have the same minus root 3 again. We'll multiply this 1, and that will give us minus 3. Now, 8 times 3 is 24. So we have plus 4 root 3 minus 6 root 3. So you check, then minus 3. Do we have like terms? Yes, of course. 24 and minus 3 are like terms. And then 4 root 3 and minus 6 root 3 are also like terms. So we will have 24 minus 3 plus 4 root 3 minus 6 root 3. Now what is 24 minus 3? Of course, is 21. Then 4 root 3 minus 6 root 3. Remember, on our simplification of addition and subtraction, we check the coefficients, isn't it? So 4 minus 6 will give us minus 2. And then root 3. And you check it out, nothing more to do here. And that marks the answer for this very simplification. Alright, we have open bracket 3 plus root 2 close bracket raised to power 2. Of course, this means we have 2 of these brackets to expand, and it's going to be 3 plus root 2 into 3 plus root 2. Alright, now just the way you have been expanding those other brackets, if you like, you can also expand it this way. That is, this 3, the open bracket, this 3 plus root 2, then this root 2, then repeat this again, 3 plus root 2. That is another way of expanding the bracket just the way we have done before. So this 3 will have, of course, multiply everything here. So we have 3 times 3, 9. 3 times root 2, we have 3 root 2. Then here, root 2 times 3 will give us 3 root 2. And then root 2 times root 2, of course, is 4. Okay, that is root 4. But then, we don't just write root 4 because the root of 4 is already 2. So we remove this and put 2. So we collect like terms. 9 and 2 are like terms, and then these are also like terms. So we say 9 plus 2 plus 3 root 2 plus 3 root 2. And 9 plus 2 of course is 11. 3 root 2 plus 3 root 2 will give us 6 root 2. So we check this, nothing to do again. Right, and number 4 here, we will check this one is in basic form, this one is in basic form, but this root 32 is not in its basic form. So therefore, we have to convert it to its basic form, and we know 32 is 16 times 2, right? And the root of 16 is 4, so we have 4 root 2. So the basic form of square root of 32 is 4 root 2. And that is what we are now going to use in our simplification here. Now we are going to have 50 minus 3 root 2, open bracket 2 root 2 minus 5, then minus 5. Instead of this 32 we got 4 root 2. Alright? So we now expand any bracket we have here, and of course we have 50 here. Minus 3 root 2 times 2 root 2. Minus 3 times this will give us 6. Then root 2 times root 2 is root 4. And root 4 is 2. So we're going to have 6 times 2 here, which is 12. So that we will just write our 12 directly. Okay? Then minus 3 root 2 times minus 5 give us plus 15 root 2. And then minus 5 times 4 root 2 will give us minus 20 root 2. And already the like terms are collected. So we have 50 minus 12 will give us 50 minus 12 is 38. Then 15 minus 20 root 2 will give us minus 5 root 2. And that is the end for question number 4. Right? Then question number 5, before we talk about question number 5, there's something I want us to understand first, which is called conjugate sorts. So when we understand this and take some few examples, so that you can go back to question number 5. Conjugate sorts. Now, what do you mean by conjugate sorts? When you have two binomial sorts that you multiply and you get a rational number, and you get a single value, then we say these two sets are conjugate. But what do you mean by binomial sort? A binomial sort is a sort that has two terms. For example, if I have square root of 3 plus 1, it's a binomial sort. The two terms here are root 3 and 1. If I have square root of 2 minus square root of 5, these are also two terms of this sort, and it's a binomial sort. So by the time you multiply this one by another sort and you have a rational number, you multiply this one by another sort and you have a rational number, then we now say they are conjugates of each other. Let's, for instance, the first one here, root 3 plus 1. If I try to multiply this one by root 3 minus 1, let's work it out and see what we will have. Square root of 3 times square root of 3 is going to equal square root of 9. And square root of 9 is what? 3. Root 3 times minus 1 will give us minus root 3. And then 1 times root 3 will give us plus root 3. And 1 times minus 1 will give us minus 1. And we now discover we have 3 times minus 1 is 2. And minus root 3 plus root 3 is 0. So now see we have 2 as our answer. Okay? Therefore, square root of 3 plus 1 and square root of 3 minus 1 are conjugates. They are conjugates of each other. Okay? That is root 3 plus 1 is a conjugate of root 3 minus 1. And root 3 minus 1 is in return conjugate of root 3 plus 1. Generally now, if I have square root of A plus square root of B, then its conjugate its conjugate is square root of A minus square root of B. Okay, if you observe, you discover that the only difference here is the sign here. Here is plus, here is minus. So you also see here plus, minus. And if you try to multiply this one out, let's multiply and see what we will get. Because the basic thing here now is that when you multiply two conjugates, it cancels out any root form in it. But if they are not conjugate, then you still have a root form remaining. Now, if you multiply this, we have root A times root A will give us A. Because root A times root A is root A squared, and root A squared is A. Root A times minus B will give us minus square root of A B. Root B times root A will give us plus root A B, and root B times minus root B will give us minus B, and therefore we are going to have A minus B, because minus root AB plus root AB will give us 0. And now see that A minus B will give us a rational number. So this and this are what? Conjugates of each other. So we are going to use this concept and simplify more and more problems under SURDS. Now, before we proceed and then pick that question, let's see how we can simplify the following. Let's take some example first. Simplify the following. The first one here, I have from me here 5 root 2 plus 2 root 8 into 5 root 2 minus 2 root 8. Let's just pick 2 under this one. 3 root 2 minus 2. 3 root 2 plus 2. So, if you check these two examples, you discover the first one, 5 root 2 plus 2 root 8 into 5 root 2 minus 2 root 8. You see, they are similar. The only difference is the sign, which is plus here and then minus here. And as I have explained earlier, that means these two are what? Conjugates. So let's see how we can expand these two brackets and see what answer we will get. 5 root 2 plus 2 root 8 into 5 root 2 minus 2 root 8. Before we proceed, we need to consider square root of 8. Let's change it to its basic form. And the basic form of root 8, we all know root 8 is equivalent to 4 times 2. And root of 4 is 2, so we are going to have 4 root 2. Okay, so take note. So instead of root 8, we will use 2 root 2. And when we bring it back here will give us 5 root 2 plus, now check, it's going to be 2 into 2 root 2, isn't it? This 2, and then root 8 is 2 root 2. And that will give us 4 root 2. So I'm going to have plus 4 root 2, then 5 root 2 minus 4 root 2. Okay? So let's expand this bracket and see what it will give us. 5 root 2 multiply 5 root 2. This 5 multiply this one to give us 25. And then root 2 times root 2 is root 4. And root of 4 is 2, so we have times 2. And instead of writing all these things to waste time, we'll just say 25 times 2, which is what? 50. So we have 50 here. Alright? Then 5 root 2 times minus 4 root 2. 5 times minus 4 will give us minus 20, so we have minus 20 root 2. Now, we are done with this one, so we now come here. 4 root 2 times 5 root 2 will give us plus 20 root 2. And then 4 root 2 times this, 4 times 4 minus 4 will give us minus 16. then root 2 times root 2 of course is 2, so we have times 2, and this times is 32. So we have here to be what? 32. And now see we are left with 50 minus 32. Okay? And then minus 20 root 2 plus 20 root 2. And then 50 minus 32 is 18. Okay? And minus 20 root 2 plus 20 root 2 is 0. So 18 becomes our final answer here. So you see 18 is a rational number, and therefore it is true that these two are what? Conjugates. Okay? So the second one, we have to be sharp with that because we've understood the concept, I believe. So you have 3 root 2 minus 2 into 3 root 2 plus 2. Now, before we proceed, I just want to give you a shortcut here now. If you observe these examples that we've considered so far, if you check, this 50 is not the same thing as saying 55 root 2 all squared. Okay? And then if you check, this is 25 and then this is 2, because this square will affect this to give us 25 and this will affect this to give us 2, which is the 50 we got here, isn't it? And then look at this other one now. This is not the same thing as saying 4 root 2 all squared, that is this 32. This one squared is 16 and then times this 2, which is 32. Okay? So I want us to just look at it now. Can't we just say this one squared, that is the whole of this squared, minus this one squared, and then we finish, so that we will not waste our time expanding all these brackets. Are you with me? Now, here, that means we just say 3 root 2 all squared, then minus this 2 now, squared, so that it will reduce the stress of us expanding this whole bracket and then able to come and cancel out now. Now check, 3 root 2 squared, that is 3 root 2 all squared. This 3 squared will give us 9 times this 2, and that will be 18. Okay, so we are going to have 18 minus 2 squared is 4, and 18 minus 4 will have 14. So following these shortcuts will save our time. So you can try expand these brackets just the way you have done it before and see whether it will give you a different answer from 14. And therefore, that is how we handle rational conjugates. That's how we handle conjugates. So we are going to also use this conjugates to simplify or rationalize fractional sorts. Okay, with 2 terms in the denominator. Remember in the previous lesson, we considered how to rationalize with just only a single term in the sort in the denominator. But in this case, we are going to consider 2 terms in the denominator of our fraction. So, we proceed. Having understood the concept of conjugate sorts, we are now going to apply it to simplify sorts that has conjugate binomial sorts in their denominators. Because if you have something like 3 all over root 2 plus 1, for you to simplify this, you need to apply the conjugate of the denominator. So, we are going to pick some examples here. Example number 1. Number 1 says simply express root 5 all over root 7 plus root 5 in the form a plus b root c. Now, to do this, we are going to simplify the whole of this and see how we can obtain something of this nature in our result. Alright, solution. Our question is square root of 5 all over square root of 7 plus square root of 5. Now, to do this, we what? Rationalize. How do we rationalize this? We are going to multiply the numerator by the conjugate of the denominator and also multiply the denominator by its conjugate. So the conjugate here, the conjugate of this denominator is going to be what now? Root 7 minus root 5. Remember our concept of conjugate? The only difference is the word, the sign in between. Okay? Here is plus and then here is now minus. If here were minus, then our conjugate is going to be plus here. Right? So, when I say we multiply both the numerator and the denominator by this conjugate, that means we are going to now have square root of 5 divided by square root of 7 plus square root of 5 times square root of 7 minus square root of 5 divide square root of 7 minus square root of 5. And you carry out this multiplication. This 5, now we treat it as a bracket. Okay? So this 5 here, the root 5 here, will multiply this and will also multiply this. And that will give us root 35. That is root 5 times root 7 will give us root 35. Then root 5 times root 5 will give us 5, right? Because we're going to have root of 25, and root of 25 is 5, isn't it? Divide by. Now, using the last example I explained concerning conjugate, we will just apply the shortcut. That is, we'll have it to be root 7 squared minus root 5 squared. Instead of us to do all this long multiplication, this way we will make our work faster. And this will give us square root of 35 minus 5 divided by 7 minus 5. Because this square now will cancel this root, and this square will also cancel this root, and then we'll be left with this. Okay? And our next step is going to be root 35 minus 5 all over 2. That is 7 minus 5. Okay? Now they say our answer should be in the form a plus b root c. So can we rearrange and have something of that nature? Of course we can do that. And that means we will have it to be minus 5 plus root 35 all over 2. And this will give us minus 5 over 2 plus root 35 all over 2. And that marks the end of this very question. Now if you look at it, 35 doesn't have a perfect square as one of its factors, and therefore there's nothing to do here. If not, I would have said let's express it in its own basic form as well. And if you are to ask to write what A, B, and C are, then our A is going to be minus 5 over 2, our B is going to be 1 over 2, and then our C is going to be 35. Right? And that is our answer and our solution. Let's take another example before we go back to that question 5 that we left. Okay? Question 2 says simplify simplify 1 all over root 3 minus 2 minus 1 all over root 3 plus 2. Now, to simplify this very expression here, you can carry out this in two different ways. The first one is you can find the LCM, and then we know LCM now, you simplify it as a fraction, or you can rationalize this and also rationalize this, then you subtract the two results. So, solution. For us to understand the concept of rationalization very well, we are going to apply that here. Okay? So I will pick 1 all over square root of 3 minus 2. Then to rationalize this, the conjugate of root 3 minus 2 is going to be what now? Root 3 plus 2 divide root 3 plus 2. That is the first part here. Then minus the second part, I have 1 all over root 3 plus 2. To rationalize this, the conjugate is what now? Root 3 minus 2 root 3 minus 2. Okay, so I'm rationalizing each of them what separately. Alright, 1 times root 3 plus 2 will still give us root 3 plus 2 all over. As I explained earlier, root 3 times root 3 will give us root 9, which is what now? 3. Then root 3 times 2 will give us 2 root 3, and then minus 2 times root 3 will give us minus 2 root 3, and minus 2 times 2 will give us 4. Right? I'm trying to go the longer way now so that you understand our expansion of bracket. Okay? So, this one too, 1 times root 3 minus 2 will give us root 3 minus 2 all over. Root 3 times root 3 is root 9, and root of 9 is 3. Root 3 times minus 2 will give us minus 2 root 3, and then 2 times root 3 will give us 2 root 3, and 2 times this will give us minus 4. Alright, looking at the first bracket here, you see that this place is now going to be 0. That is 2 root 3 minus 2 root 3 is 0. So we are left with root 3 plus 2 all over 3 minus 4 will give us minus 1. Then we have minus, we have root 3 minus 2 all over minus 2 root 3 plus 2 root 3 is 0, and we have 3 minus 4 is also minus 1. Alright, now that is to say that, remember they are in brackets like this, that is to say that here it is the same thing as root 3 divided by minus 1 is going to divide by minus 1 is also going to give us minus 2. Then minus, here we have minus root 3 as well, and then plus 2. This divide this, we have this, and then this divide this, we have this, isn't it? So we are now going to use this minus to open up this bracket, and that will give us minus root 3 minus 2 plus root 3 minus 2. If you collect your like terms here, we are going to have minus root 3 plus root 3 minus 2 minus 2. Minus root 3 plus root 3 is 0. Then minus 2 minus 2 will give us minus 4. And that is our answer. Okay? Now,